All right, everyone. I am here with Swami Sivasubramanian, who is Vice President of Amazon Machine Learning. And we are going to be chatting about all of the news that came out of the reInvent conference over the past week or so, as well as pre-invent, as it's come to be known. But Swami, great to have you on the show. Welcome.
Hey, pleasure to be here. So usually we meet during, during reInvent in Vegas, but I'm glad at least we could do this virtually.
Absolutely, absolutely. That has become a highlight of my visits to reInvent. Last year, in particular, we had this amazing dinner at I forget the restaurant in Vegas, but we had the opportunity to sit next to one another and chat a little bit about not just the work stuff, but fun stuff too. And I think if there's anything I miss about the times we're in nowadays and doing everything virtually, it's opportunities like that. But as you say, great to have you here virtually.
Me too. Really looking forward to the conversation.
So let's start by having you share a little bit about your background and help the listeners get to know how you came to work in ML.
Sure. As you mentioned, I run machine learning business for AWS. I've been at AWS and Amazon now for more than 15 years or so. So joined Amazon and AWS as an intern during my PhD. So, and my background during my PhD was in distributed systems, building large-scale technology and so forth. And my internship project was to build a large-scale database system because the underlying Oracle database for Amazon.com couldn't keep up with the scale we were growing. So as an intern, I joined the team and we were discussing saying we can build something better. So, and Amazon being Amazon, he said, if you can build better, then let's go build. And so we did build what came to be known as Dynamo. So, and now Dynamo, the cloud version of Dynamo is DynamoDB, which is a major building block service that is used by many of our AWS customers. And since then, I joined along with Werner and Werner Vogel, CTO of Amazon, to build a bunch of our AWS services, including our storage service S3 to our relational and then non-relational and big data service too, and so forth. At some point, one of the things I realized is that machine learning was at a critical moment where suddenly all the elements that were blocking machine learning, such as the access to huge amount of compute and the requirement in terms of having reliable and secure and cost-effective access to compute and data, was suddenly made possible due to cloud. So, and especially the deep learning programming frameworks were getting easy enough that non-experts, people who do not have a PhD in machine learning, people like me, for instance, who didn't do a PhD in ML, they could be able to program using machine learning, so and build some amazing things. So during one of my trips to India during my vacation, where I was taking my 1-year-old daughter to visit her grandparents, since I had a lot of time to kill. So I started playing with a bunch of early deep learning models and on Cafe, because I didn't think even TensorFlow was launched at that time. Then realized the power of potential and of deep learning. So we came back from vacation and then bootstrapped the machine learning team. And Amazon, we have been doing machine learning for 20 years. So, and at that time we had a bunch of efforts in like our Alexa and various other places. And that led to a lot of learnings. And by talking to several of our internal teams and tapping into experience of what does it take to apply machine learning to some of the core business problems, then it led to me formulating the strategy around what does it take to make machine learning accessible to millions of AWS customers who are using us on a monthly basis. So that like our entire tier of machine learning investments, and that's the short story about me. So.
What an incredible story! I don't think there are many interns that can tell that story. Not to send us back to reminiscing about reInvent's past. I've been to most of them since the very first one, having spent a lot of time in the cloud computing space before ML and AI. But one of the things that was new and noteworthy this year is that you delivered the first ML keynote ever at reInvent. Am I getting that right?
Yes, and that was due to a couple of reasons. One is that, as Andy put it, we have so much innovation happening in machine learning in this space that last year alone, Andy spent 75 minutes in his 3-hour keynote on machine learning. This year, we figured that there is no way, unless that keynote becomes a 5-hour keynote, we can't actually put everything together in it. So we ended up saying, hey, let's do a separate machine learning keynote. And it so happens between Andy and my keynote, we still couldn't cover everything because there is so much innovation happening in this space. But it's also a symbol of how much machine learning has transformed from being a niche investment to actually becoming core of every business strategy. So, and that's such an incredible moment. It kind of reminds me of when I got out of grad school and saw where AWS was truly changing how people build applications. I kind of see the same thing happening right now in terms of machine learning going from used by these brilliant data scientists and amazing scientists to build some really interesting proof of concepts to now it's becoming mainstream where people are using it now as a regular part of how they run their business, all the way from like Domino's Pizza. I mentioned this in the keynote about them using machine learning to do predictive ordering to deliver hot, fresh pizzas in 10 minutes or less. To Roche using it to do tailored medicines, to Formula One using it to do better car design. This is literally happening in every industry segment. And this kind of innovation is, from our customers is having us also drive so much in terms of building the right tools for them so that they have the freedom to invent. And that's what we were excited to showcase on all the innovation and invention happening in each layer of the machine learning stack. And how our customers are using these building blocks across various industry segments to also innovate as well.
Yeah. Well, what I thought we'd do is spend some time up front kind of reviewing the announcements coming out of reInvent. And I think I want to focus on kind of Sagemaker, but to contextualize that, I think you and AWS generally and the industry more broadly has started to coalesce on thinking about machine learning tools and platforms as part of this 3-layer cake, kind of like we did on the cloud side, where we've got kind of ML enabled or enabling infrastructure at the bottom, like GPUs, for example, and then tools that are used by data scientists in the middle of the stack. And in the AWS world, that's Sagemaker. And then at the top of the stack, these kind of ML as a service or cognitive services, depending on what you want to call them. And there have been announcements in all of those at reInvent. But let's maybe jump into that kind of core middle, the Sagemaker piece, and we'll circle back to some of the other stuff as well as some applications. I'm wondering if you have a favorite new feature or announcement out of all of the new stuff.
It's like asking me to pick my favorite child. Even though in the real world I have only one child, she is 5. But I have a dog too who competes pretty well with her. But that's I mean. The thing about SageMaker is, even as I mentioned in my own personal story, machine learning historically has been a domain of expert practitioners who actually were willing to get their hands dirty and go and figure out all the way from not just preparing and collecting data to also uh, picking the right algorithm through trial and error to actually tuning the parameters to then figuring out deployment. And then they talk to ID ops to handle and deploy. And as a personal builder myself who likes to build things, one thing I realized, this is not going to help us scale and to millions of developers. And this means only very few companies who have um, the necessary resources to productionalize machine learning will actually make it will use it. So that led to us building SageMaker, which is an easy service all the way to build, train, and deploy ML models in the cloud. And um, since the launch in 2017, it has been one of the fastest growing AWS services in our history. And already tens of thousands of customers are using it in production, virtually in every industry segment, and seeing significant acceleration in terms of being able to build, train, deliver. This reinvent, what I would say, a few things I'd call out. The number one I continue to hear since launches, even though we have made the process of building and training and deploying easier, data preparation especially was one of the messiest part, and they said it is totally undifferentiated for them because not only do you have to collect your data from, let's say, various storage service like S3 or Redshift or Athena, to you have to write code to transform your data and then visualize to inspect errors and then figuring out and exporting it to production. This could be drastically simplified. That led us to build SageMaker Data Wrangler. We have gotten like great feedback from customers on how simple it is. But we didn't stop by just giving an IDE and a tool for data wrangling. We connected it to not just popular AWS sources, but also we are connecting to other partner sources like Snowflake and Databricks, Delta Lake, and MongoDB as well. Because we do want customers to be able to connect to the data sources and get going. But then we also built the feature store, which makes the process of the feature management, both for training and inference, a lot easier. So, and when we work with customers like Intuit, one thing they mentioned is they had to essentially build like 2 versions of feature store. One for feeding it for the training pipelines, which means large batch access focused on throughput, and for real-time access for inference. And then they had to do a bunch of engineering to keep them consistent. And this is where we built an end-to-end fully managed feature store and made it available for SageMaker. And then we launched also the full CI/CD pipeline. As software engineers, they typically have a full-blown stack all the way from debuggers, profilers, and CI/CD and so forth. In ML, these are still not there. So, and we want SageMaker to make that process easy. So that led us to build pipelines. To me, 2 of the things I'd call out is along with launching debugger and profiling features. But the bigger one, my opinion, is when we talk about data, one area that we were very interested in making this process less of a black box and more easy for our developers to be able to understand is around detecting bias in machine learning workflow. So, and while bias is a very strong topic everyone thinks about, but you got to demystify the one to understand, is there a bias in the underlying data when you prepare it for training, to all the way from also in the inference, what features are going into when it is making a certain decision. So that led us to creation of Sagemaker Clarify, which is a capability that helps detect bias in the ML workflow as well. And then the final step is around Sagemaker Edge Manager, which makes it super easy to build M models in the cloud and deploy at the edge and manage across fleet of devices.
So you did not let me make you choose one of your children. Well, you left out SageMaker Jumpstart and maybe one other small feature.
That is true. I would hate to call anything small because it is all done by a 2-pizza team. So it's Jumpstart is another great innovation too. You just reminded me of, because again, I put myself in the 4-year prior to where I was. Machine learning can be intimidating for people who are not grown up and played with it for a long time, and you need an easy way for them to get started with. And that was the idea behind Jumpstart, saying, like, if you're interested in this problem, here is a pre-cooked recipe, and with just a few clicks, you can get up and running. Is something that is resonating with a lot of customers, because I want to make this super easy for them to experiment and actually also learn along the way. And I mean, of course, we also had a few more like faster distributor training with data parallelism and model parallelism. You're reminding me of all the things we just watched.
Yeah, well, I think I can give you my list. The things that jumped out at me were Data Wrangler, Feature Store, distributed training, and pipelines as the most interesting of the announcements, relative to the things that I'm seeing in the market and from talking to users. Starting with Data Wrangler and Feature Store, I think they're individually interesting, but they're also interesting together as kind of representing a big step in trying to wrangle this data part of the problem that's so challenging for a lot of people. Like SageMaker has long billed itself as end to end, and it's had some capability on the data side of things, like ground truth and others, but hadn't yet really taken hold of the bear, so to speak, of preparing data for training and serving features and things like that. So I thought that was interesting. The other interesting thing there was with Data Wrangler. I guess maybe my view of AWS is dated, but I think of AWS as like this API first company, and not really having strong UI with regard. I think of the console and like just 1,000 links to different services as opposed to UIs. But Data Wrangler and pipelines are both very kind of visual features. Data Wrangler in particular looks every bit of what I'd expect to see in dedicated data wrangling, data prep offerings, at least as a first step. And I'm curious, maybe just to drill into Data Wrangler a little bit more, if you can kind of elaborate on what are the core capabilities of that feature, and kind of really what it took to make it happen at the scale that AWS operates.
Sure. As you're calling out, I mean, Data Wrangler was one of the core capabilities, especially that came up as a top ask when we saw customers were moving from, let's say, one model to 100 model to 1,000 models and so forth. When there's usage of machine learning started to scale, this became more and more important because when you're doing one ML project within an organization, having a separate data prep team and so forth work. But if you have like 1,000 ML projects, you want each team to be self-sufficient and get going instead of having to do a separate data pre-processing team for transformation and then handing up to data science team. So now with Data Wrangler, that's why we built it as an integrated experience in Sagemaker Studio with making the process of collecting and preparing data so you don't have to write custom queries to query from S3 or others, all the way to connecting to Redshift and in future many more sources. But then even for transformation to do simple things like converting integers to floating points or various other text labels into numbers and whatnot. We actually had like 300 plus transformers that you can write with a single click to finally also visual inspection of these data because even internally when we use these things, it's not just about the ETL part. You want to visualize the data, diagnose issues in them and see, hey, are there any visual inconsistencies and so forth because it's an experimentation stage. That's when you want to see if the shape of the distribution is correct and whatnot. And then have an easy way to put it. So we address all these 4 steps in a single end-to-end system using Data Wrangler. The feedback has been really great so far. And I think this coupled with, this is great for structured data and ground truth is really good for the unstructured when you're trying to annotate. So we are kind of addressing both in parallel so that then you can quickly move to the build side to where the algorithms and start going. So now people have a single pane of glass for the end-to-end ML development workflow. So that was the idea behind it.
And some examples of the kinds of transformations that you can do with Data Wrangler are things like you can one-hot encode a categorical variable, or you can do missing value imputation, things like that. And then all of that, it looks like you can export to Python. And the example that I saw, the Python wasn't even necessarily calling SageMaker libraries. It was just straight Python. Is that always the case, or does it depend on what you're doing?
It depends on what you're doing, but you can export it as a pure script and run it and in the context of the SageMaker Data Wrangler instance. But you can also export it into a notebook script as well. I think we provide both options. But I think the goal is to make sure, again, in that example, the productionizing of the data prep workflow used to be a pain point where people who used to prepare data, then they had to engage with a dev team to build the production quality of what they call this data prep. And I don't think we wanted that kind of disconnect between one team that does experimentation and one team that does productionization. And instead, we wanted it to be simpler. So that's why we actually made it as a simple one-click export step as well.
And so the next big feature on my list on the data side is Feature Store. I'm actually going to not go into a lot of detail in this conversation because next up in this series or in a future show in this reInvent series, we've got a conversation planned with the team at Intuit, which was one of your customer partners in developing this, and we're going to go into a bunch of details there. But maybe next we can talk a little bit about pipelines, which is another really interesting new feature. So pipelines has several different components. You want to talk us through those?
Yeah, sure. I will keep it at a high level because I think we have like some really interesting things, even more to cover on things like the code for vision and whatnot. But the key thing I'll call out is, as you know, and many of your readers will know, machine learning workflow tends to be not always a serial workflow. It can be that some steps can be executed in sequence and some happen in parallel with various different combinations. And there is no easy way to actually orchestrate these things, let alone to actually also have a continuous integration and deployment workflow. So this is where we wanted to make this process as seamless as possible. And we again provided a simple way, again, through a visual interface, not just through APIs, as you called it, but visual interface, so that you have an easy template to get started for things like model deployment and also virtually anything you can do in Sagemaker. Now you can actually track as part of your end-to-end pipeline as well. So that was the idea behind pipeline, essentially to scale and bring the end-to-end CI/CD process as well. So again, this becomes a lot more relevant when you're trying to scale your usage of machine learning. Like what I mentioned that you're going to talk to Intuit, their usage, if you're scaling from, let's say, one model to hundreds to thousands or tens of thousands, then you do want to operate at a scale where you treat it like software development, and you want these kind of CI/CD style pipeline. And that's exactly what pipeline does as well.
Mm-hmm. And that one thing I noticed was that pipeline component is built on some other AWS products that I'm not quite as familiar with: Code Commit, Code Pipeline, Code Build. I'm assuming those are like the kind of the DevOps, core DevOps components from the app dev side, and it's reusing those to create the ML version of the CI/CD pipeline.
Yeah, I think as in true AWS spirit, when we try not to reinvent the wheel. There are certain abstractions that work well for the use case we try to do. We want to be able to reuse them. That's one of the reasons why we don't try to build yet another service if we can have some of the regular DevOps components that can be applied here, but with where we need to connect the dots more from the machine learning side as well. And I think, and we'll continue to iterate as well based on feedback where there are more gaps needs to be filled as well.
Mm-hmm. And then also tucked under pipelines is a model registry for folks that want to be able to have like stable model artifacts. Is that, I'm curious how you envision, or some of the customer stories do you have specific customer stories that drove you to focus on model registry as part of that?
I don't have anything that I can recall, but I'll be happy to have the team come back and share it with you. So, but again, this speaks to probably some direct customer feedback we might be hearing as they are scaling for sure. So,
awesome. And then, so moving off of pipelines, the next one on my list was distributed training. And you went through the couple of different types of or flavors of distributed training in your keynote. Walk us through the highlights there.
As we actually started to, I mean, as for context, in AWS, we provide a huge, broad and deep set of compute storage and network infrastructure for expert practitioners to be able to train ML models. And the latest in that instance is P4D instances, right? They feature the NVIDIA A100 GPUs with 400 gigabit per second networking stack. And they offer like supercomputer class performance with these C2 Ultra clusters. But one of the areas where we did continue to hear is, especially as in specific instances of deep learning models in computer vision or NLP models, they were hitting the limits on being able to deploy this trained models as fast as they would like to, or either because such as Mascar CNN, which is a computer vision model used for a lot of use cases, including autonomous driving and whatnot by our customers. They have a huge, they process a lot of data to build these models. And our customers wanted an easy way, or rather easier way to actually scale with huge amount of data inputs to be trained. Of course, for us, it's a well understood problem. Doesn't mean it's well solved, but is around to do data parallelism, where you actually spread the data across multiple GPUs and train them and so forth. And on the T5 with like 3 billion parameters, that's a lot of big model size, which could be even bigger than the biggest GPUs. And that required a lot of developers to having to rewrite even how they program these models to split them across to do model parallelism. And looking for a more managed way to make these processes easy. And that led us to build these managed distributed training with built-in data parallelism and model parallelism. And feedback so far from customers have been great. Even the data parallelism makes training up to 40% faster for some use cases. And the time to do model parallelism has drastically decreased. What it used to take a bunch of handcrafted code, now it can be done in an automated fashion as well. So again, a lot of great feedback so far. But this just speaks to another our approach in this front, in the sense that we want to continue to iterate based on customer feedback on this, and that is why this led us to continue to optimize here. And I still think as customers scale more and more, we are going to find more and more next gen set of bottlenecks here that we want to go and fix as well, both at the infrastructure but also at the frameworks and algorithms level too.
Mm-hmm. Yeah, the distributed training is one that I found particularly interesting, and I'll refer folks to the blog post about that. We'll drop the link in the show notes, but there's a really nice explanation around kind of the evolution of distributed training from things like Harvard that had these centralized parameter servers for exchanging gradients, and then efforts to kind of scale that out by distributing the parameter server. And the distributed training here is based on this algorithm called all-reduce that essentially shards the parameter servers and has those running on the CPUs that are local to the GPUs that are doing the compute. And those CPUs like pull together all the messages and make it all work. And the end result, I don't have the specific numbers, but you alluded to the percentages. But on the examples given were that the Mascar CNN and one of the big transformer T5, like 3 billion parameter transformer model, pretty impressive training time savings. And ultimately, from a developer's perspective, they're swapping in a line of code or something along those lines, right?
Exactly. With a few lines of change of code in Python for TensorFlow or PyTorch, they're able to leverage this. And it's kind of like what AWS has done for traditional IT. We want to do the same to make them move faster for sure. Yeah.
Cool. And then on your list, you had the debugger. The debugger, I remember the debugger, the debugger was introduced last year. And I remember the focus of the debugger being, I remember it as being explainability and like Shapley values and that kind of thing. That the focus on explainability and transparency and bias has now moved to clarify, and the debugger is shifting a bit and focusing on lower level profiling of training jobs and exposing the various infrastructure metrics up. Am I getting that right?
Yeah, specifically, we here launched deep profiling for debugger to focus on giving more visibility into resource utilization. Because as you called out, even in the training phase, the CPUs and GPUs and network and IO, they all need to play together, and they need to be able to drive to maximum resource utilization for our customers to be able to train faster, but while doing it cheaper. And this is where there was not an easy way to run a training job and figure out something like, hey, I am actually spending a lot more time in the data processing at the CPU side while the GPU is sitting idling and so forth. Well, you could do it by putting together framework-specific tools for each and everything you're using and cobbling a bunch of them together. It's not as easy, as intuitive as it could be. So that's why we provided the deep profiling capability that integrates with the training part. So it's kind of like having the equivalent of software profiler that goes into the entire application stack. We are trying to do the same for the training side as well. And then we are making the process of being able to give visibility into how the various features and what kind of impact it has on the end-to-end machine learning workflow on data distribution and any bias, and how to explain which features and to clarify as well. So,
Awesome.
So, yeah.
And then you briefly touched on the Edge Manager. AWS has been doing stuff with IoT for a while on the cloud side, Greengrass and other offerings, and even dabbling with AI on the edge and things like Deep Lens. But this is kind of getting serious and taking a different approach. Can you dig into that one a little bit?
Yeah, I mean, Edge is one of the important areas where I do see machine learning going, because people do want to make a bunch of decisions at the edge. But historically, building ML models for the edge has been challenging because the hardware, server, memory, compute, all these constraints are very different. And not only do you have to hire these amazing machine learning scientists, you have to hire also great hardware and systems engineers who can actually connect the dots between these two. And to address this, we started on this journey in 2018 to build Neo, Sagemaker Neo, which is also available in the open source, to build the models and train them in the cloud and deploy one of those models in the edge. But to scale truly your edge deployment, you have to still do things like you got to manage your models on fleet of edge devices. And then you got to be able to deploy multiple models in the edge. Nobody just deploys one. They end up to run an application at the edge. They have to manage multiple models in there. And then also identify if there are any performance issues in the edge and accuracy issues, and then monitor for them and notify so that you can take action accordingly. So these challenges led us to significantly improve our offering and build Edge Manager so that you will have a fleet-wide edge manage your model deployments across fleet of edge devices. And then we run model monitor at the edge to also detect if there are any issues on accuracy and others that we want to be able to monitor and notify so that you can look at it and then kickstart a training job or whatnot. So that's
and this is a hardware plus software offering. Is that correct?
No, the Edge Manager is completely pure software that you can deploy, and the core ingredient, what we did 2 years ago, Neo, is already powering a bunch of things like your Alexa devices and so forth. But this one is more scaled out version.
Okay.
And then you might be talking about the next version on the AI services, where we launch a bunch of capabilities all the way to things like Lookout for Vision, where we provide a vision capability to do things like industrial customers to do like product quality inspection, and then our edge device capability with Panorama and so forth.
I think that is what I was referring to. There was, separate from Sagemaker, there was a handful of interesting kind of AI for industrial use cases announcements that were made this time around.
Yeah. I think I'll say that we launched like 5 industrial machine learning services, primarily focused on 2 major buckets. One is around preventive maintenance. And then that bucket, we launched an end-to-end system called Monotron, which consists of sensors and gateway to send the sensor data, and then with the back end of a machine learning service to detect if something is wrong. And then notify factory floor technicians saying like, hey, this machine, the RPM vibration seems to be abnormal, or temperature seems to be abnormal. You might want to get it checked. We deployed it in cases like our own fulfillment center, and it has led us to avoid costly downtimes. Then we also provide a capability for lookout for equipment for customers who have their own sensors, but they don't have the time or skill to deal with building an ML service to do anomaly detection and correlating all these things specific to equipment. So we provide it as an API. Whereas the previous one is an end-to-end working system with the mobile app and so forth, along with the device. The other bucket is how do you make computer vision deployments easy for industrial customers? And there, the number one was lookout for vision. So when you talk to computer vision scientists, they talk about things like few-shot learning and to do some amazing things. And we have come a long way in computer vision, but lookout for vision, it makes it super easy. I, as a customer, can upload 30 images to detect for a particular thing is the right quality or defective. I'll give an example of Dafguts. It's a customer, it's a frozen pizza manufacturer in Sweden who produces 2 pizzas a second. And they wanted to be able to ensure that the pizzas have the right amount of cheese and the right toppings, and you cannot not have enough cheese, right? So, and if you think about it, it is a very complex computer vision problem, and I think that lookout for vision, they were able to do this really simple, and there is a fascinating story on how we built the few-shot learning algorithm. If we had the time, maybe I'll spend a couple of minutes to go do that afterwards. But let me complete the other end. Now, lookout for vision, it is getting used not just by pizza manufacturers, but like healthcare device manufacturers to do, like GE Healthcare, to do things like inspecting healthcare device production quality and so forth. On the other part of the computer vision is to make the deployment and management of these computer vision applications at the edge. So we launched Panorama Appliance so that you can hook in your existing camera streams in the industry and be able to start running computer vision models based on the models you built on the cloud using Sagemaker and deploy as well. So, yeah, I think we are come a long way as an industry to make it easy. But I think our industrial customers have really responded well. They actually feel this is really breaking the barriers and making these more accessible for them. So, and this did require a lot of solving some really hard problems that I was hinting about. So.
Yeah, please. The comment I was going to make was more kind of observational around the level of readiness and maturity around for ML and AI in industrials, and any thoughts you had on that. Those, as a category, we often think of industrials as laggards, but of course we all know that there are many companies that are far out ahead. Oil and gas, for example, has been doing ML for a long time in different areas, and there's robotics and things like that. And I'm curious if you have any kind of meta commentary around your working with that industry.
I think when we talk to industrial customers, one thing that we notice is they are very, very, excited in adopting new technology that improves their quality, the products that they are producing, and helps with automation. And also helps prevents downtime. So to them, to a large extent, machine learning is a means to an end than the end in itself. So that's why instead of just providing them, hey, here is a few shot learning API, we had to go build Lookout for Vision. Instead of saying, hey, here is an anomaly detection API for time stream data, we had to go build our Lookout for equipment, which is very specific to sensors and so forth. I think they wanted us to connect the dots more instead of saying, like, go hire a team to go procure sensor hardware, procure IoT gateway, and so forth. So, because they have huge number of other problems they need to go solve on their day jobs. And that's exactly what is one of the tenets in my organization, is to solve the business problems end to end. Instead of just solving it only 70 to 80% of the way. And it does require a lot of different invention altogether. As I mentioned, even in the Lookout for Vision, while there is a lot of research that gets published around few-shot learning and so forth, how do you think about collecting data for industrial? I think my team had a really great idea, think big idea around. They ended up creating a mock factory with conveyor belts and various products, different kinds of cameras, then we collected data, and then. And as you very well know, it's unlike traditional software. Machine learning projects tend to be a lot more experimentation oriented. You collect data, then build algorithm and see if it works, and then iterate on the data, saying I need different camera angles, and it is a lot more experimentation. This was an incredible think big effort, and our customers have really responded well. That's why the gamut of application that it was able to do, right from frozen pizzas to being able to produce, also help on the healthcare devices side, shows that it really is incumbent on us to go help solve the real business problem by connecting the dots more to our customers. And that's what we try to do here. So yeah, a lot of details on some of the ideas behind, let's say, Clarify, or on Health Lake, where we talk about how do you build an healthcare data lake, where we actually enable in the future, hopefully, things like precision medicine or personalized medicine using AI, ML, or even Lookout for Vision. We have some of them written blogs about it in Amazon.science. Highly encourage checking them out too. So
awesome.
Anyway, I know we ran out of time, or we went over. So
yeah, we did. If you have time for one more, I would ask you to speak briefly to Trainium. So AWS previously announced Inferentia, which is an inference chip and hardware, and this time around, Trainium was announced to address training. Any quick things you could say there?
The thing is, with Inferentia, since we launched we have gotten great feedback with Inferentia that it has saved, for instance, significant amount of cost for our customers. Like our own Alexa devices, when they moved to Inferentia, their models ran like 25% faster for text-to-speech workloads, and then customers like Snap, Containers, and many others are switched over to Inferentia. Containers saved, I think, up to 70%. So when we saw all this happening on inference, which in our experience, we found it to be the 90% of the cost for production ML applications.
Mm-hmm.
But in reality, the other part is during the experimentation stage, because the cost of training was so high, so we ended up, people ended up self-throttling and not training as often as they would like. And that led us to invest in Trainium, where our goal is to create the best price performance ML training chip in the cloud. And we wanted to have first-class support for TensorFlow, MXNet, and PyTorch, and we will use the same Neuron SDK as what Inferentia uses. So customers who use Inferentia, they can quickly get started with Trainium as well. And this is a space where, given how much innovation is happening, that's why we're investing heavily as well. Once again, thanks for the opportunity again, Sam. I know.
Absolutely. I know you've got to scoot, but as always, it's wonderful to have a chance to connect with you, and I appreciate you being so generous with your time.
Hey, thanks again. And hope we see you in person next year. Agreed, man. Okay.
Absolutely. Take care.
Bye.
Bye.